All right, Chapter 5, Section 2. Chapter 5, Section 2. We're going to start learning how to multiply polynomial factors. Now, what they're doing in here is they're giving you three numbers. All right? We're going to put that into this type of equation. In other words, what they're doing is they're saying x minus a1, x minus a2, and x minus a3, and we're going to multiply all three out. This starts to happen with distribution. So my three numbers I'm going to put in here are 0, 4, and negative 2, which makes this a positive 2. So if we put those in, we actually come out with x minus 0 is just x, correct? Why would you do that to me? I want to do this. Make it this way. Get rid of this. And look at this. We would just have x here. We'd still multiply times x minus 4 and x plus 2. We're going to put this into one big polynomial equation. Regardless of what you're going to do, you're going to have to multiply this through somehow. I'm going to take these two right here and multiply them together. Now, this is where we distribute through. We multiply our x times an x times a 2. Then negative 4 times a x, then negative 4 times a 2. All right, so we multiply by each one of them. Put this x out front. X times x is x squared. Everybody see where I got that? X times plus 2 is a plus 2x. Everybody see that? Negative 4 times x is a negative 4x. Negative 4 times 2 is a negative 8. Now we can combine like terms. Let's leave our x here. There's only one x squared, so we'll leave that. There's a plus 2x and a minus 4x. We combine those two, we come up with minus 2x. And then there's only one negative 8. The last thing we can do here is carry our x through. Multiply it by each one of these. So x times x squared is x cubed minus x times negative 2x. So negative 2x squared minus 8x. So that is our solved from that. That would be your answer. Okay? Now, we've just multiplied through by... No, we just multiplied through by an x, which was pretty easy, right? It gets a little bit more difficult. I'm going to do number 2 here. I'm going to do number 2 here, which is a 1, 7, and negative 5. So x minus 1, x minus 7, and x plus 5. I've got a negative 5 here, and that's why I put a plus 5 up there. Now, I'm going to pick 2 of them. I'm going to multiply them together. I'm going to take these 2 here and multiply them together. Leave my x minus 1 out front. X times x is x squared. X times 5 is a plus 5x. Negative 7 times x is a negative 7x. Negative 7 times 5 is a negative 35. Pretty easy, right? We can combine like terms. X minus 1. And I go x squared minus 2x minus 35. Now here's where it comes a little bit more difficult. Now we have to multiply our x by each term and our negative 1 by each term. This gets kind of big. All right? Let's multiply my x times x squared is x cubed. X times minus 2x is a minus 2x squared. X times 35 is a minus 35x. Now let's multiply through by the negative 1. Negative 1 times x squared is a minus x squared. Negative 1 times 2x is a plus 2x. Negative 1 times 35 is a plus 35. Now we can combine like terms. A little bit more difficult, right? Just a little bit more. All we had to do is we had to make sure that we hit each one of these terms with each of these values. So I'm left with an x cubed. I got a minus 2x squared, and I got a minus x squared, minus 3x squared. And if you want to, if this is going to make it easy for you, as you put it down here, cross it off. All right? Cross it off so you know you've got that pulled down, you've combined. I've got a minus 35x and a plus 2x, minus 33x. Cross them off. What am I left with? A plus 35. And that is your answer. All right? So it's a little bit of busy work, but you can help yourself by doing this kind of stuff here. Even if you have to, do this kind of stuff. How many notes did you guys take? You got this, huh? All right. All right, let's see. On the back, no, you're going to start using a little bit of word problems to this. It's the same thing, guys. It's the same thing. Don't get worked up by it. Same stuff. Okay? Your school wants to put in a swimming pool. The school wants to maximize the volume while keeping the sum of the dimensions at 40 feet. The sum of the dimensions. So if I have a pool that's 20 by 20 feet, right, that's sum of my dimensions. Yeah, equal 40. So we probably go 10, 10, 10. It's a small pool. If the length must be 2 times the width. Okay, so we got to think about this. I've got my length. If this is x, 2 times the width is 2x, right? All right. What should the dimensions be? Well, we got to figure our depth too, right? If we're going to figure this in, let's see, how can I do this? I'm going to do it this way here. There's my depth. And now my pool's kind of laying on its side. That doesn't look right, does it? We're gonna make a different pool here. We've got our pool like this. All right. Let's see. This goes like this. This goes over here. There. Nah, that's not quite right. This goes over here. All right. Anyway, so we've got our width at x. We've got our length at 2x. And let's see, what does it say about the depth? Length is 2 times the width. Let's say anything about the depth. Oh, okay. Our depth here, our depth is going to be what? 40 minus 3x, or 2 times our width and our 2x plus 3x. So if we add it, remember it says it's the sum, right? Where does it say this? The sum of the dimensions are at 40. Yes, but when you sum these up, when you go x plus 2x plus whatever this is, right? A sum would be x plus 2x, and then that would have to plus some number, let's just call it y, has to equal 40, right? Right? Sum has to equal. So what we could do is we could sum these up. This is 3x here, and bring it to the other side. So y would equal 40 minus 3x. This here is 40 minus 3x. You see where they came up with that? 40 minus 3x. So what did they do? They multiplied them all together. It was a word problem. We multiplied them all together. Move this down. We multiplied them all together right here. Our 2x, our x, and our 40 minus 3x. Right? See how we came up with that? And this is what we got. That's the equation that they need to be able to figure out what the pool is. Now they can come in here and graph polynomial and all that. This is what I'm interested in. You coming up with the equation for these word problems. It's going to take some thinking. What's that? What do we got in here? Find the dimensions of a swimming pool if the sum is 50. Well, what do you do different? And the length is 3 times. You see what you have to do? You have to interchange some numbers, right? Instead of 40, it's 50, and instead of 2x, it's 3. Okay? And it says here, the length must be 3 times the depth. The length is 3 times the depth, so what would the length? Length is 3 times the depth. So we'd set our depth at x, right? We'd set our length at 3x. What would our width be of the pool? 50 minus 4x, right? Right? That would be our width. So that's how it changes up in here. That's the kind of things they want you to do. 11, 12, 13. So you guys got those to work on? All right.